Mrs. Thompson here looking at section 9.3 with the Pythagorean theorem. Our goal is to be able to use the Pythagorean theorem to solve problems, but first of all we kind of need to learn about what it is. We'll probably come back to this interactive one in just a little bit so I can show you that. But right now I want you to turn in your notes, in your pink notes if you have those out, turn to the Pythagorean theorem, application with radicals, and we are going to be filling in some of your notes. So if the triangle is right, then the thing that will work out is that, as we look at it, the sides of the right triangle, the legs squared plus the other legs squared, will be equal to the hypotenuse squared, where A is going to be a leg of our triangle, and you'll see, and it always has to be the leg of a right triangle. B will equal another leg of our right triangle. And C will be what's called the hypotenuse. So the hypotenuse of a right triangle. Now let me talk about the hypotenuse. This is actually the longest side in a right triangle. It's always going to be our longest side. So the theorem will only find lengths and sides of a right triangle. It doesn't find the area. It's not going to find an angle measure. It only looks at sides. So the key thing with the Pythagorean theorem, when you think about a squared plus b squared equaling c squared, is that it is called this, what you're doing is you're finding the sum, that's our addition, of the legs, and then you're going to square that, equals the hypotenuse squared. When you look at your right triangle, and yours there should be drawn in this right angle, and if not, please draw that in. We are looking at this being the leg, and the reason it is the leg is it is adjacent to the right angle. Down here is another leg. Does it matter which one is A and which one is B? It does not. And over here is your hypotenuse. And as I said earlier, the hypotenuse is the longest side. So this is our longest side of our right triangle. This is our C, so we're always looking at being the longest side. This is our C when we look at our picture. So this side is C, and again, it wouldn't matter if this is A and this side down here would be B, or if we switch those two around. So as you are looking at your notes, we are going to be filling in that next section, which says, if we think about what is a leg is the right angle, a leg side of the right angle is the right triangle. So A and B are legs because they're adjacent. The hypotenuse is always opposite the right angle of our right triangle, also the longest side. We are going to be looking at the converse, and the converse of the right triangle just says that when you reverse the parts in this statement, then you get a new statement. So that's what a converse is. You don't have to write that down, but I do want you to take a look at this picture. Hypotenuse, and if it helps you, is always directly across from the right angle, and the legs are adjacent, so they're right next to it. So we're going to be looking at our Pythagorean theorem, and the theorem says that for any right triangle, the sum of the squares of the legs equals the square of the length of the hypotenuse. If you would have a right triangle with sides A, B, and C, 3, 4, and 5, you're going to find that A squared plus B squared is equal to C squared. You would also find that if you have 3 squared and you put plus 4 squared, that equals 5 squared. This is one of our few Pythagorean triples that we will look at. And if you think about that, 9 plus 16, that equals 25, and 5 squared also equals 25. I do want to show you going back, looking at this application, this interactive Pythagorean theorem. And what it's showing us, maybe not, yes, it is. So this is the station, but what it looks at is if you look at sides of a right triangle, if we have 10, 10, 200. And what you can do is a squared plus b squared, and you'll see how they are equal. And if I change the lengths of the side, so if I have 6, and on my other side I want to make it 4, I have 6, 4, and 42. In this case, 52 is a 7.21. 16 plus 36. If we want to think of 3 plus 6, 3 squared plus 6 squared equals 45 squared, as we are looking at that right triangle. So it's kind of a cool thing, and if we're in class, if I'm here in class with you, we might look at this actual website. I'm not going to show the other video. I may put that at the end. We'll see if that works or not. Sometimes they don't work with the video within a video when we're doing these. So what is the converse of the Pythagorean theorem saying? It's just saying that if a squared plus b squared is equal to c squared, and this is really, when we are looking at this, the two shorter sides of our right triangle equal the longer side squared. And again, now you'll see that I have this picture in your notes. I know my right triangle is not coming out too great here. And the question says if you have a 5-inch side and a 6-inch side of a right triangle, and down here we have 8 inches, could this be a right triangle? So remember, we want to take the two shorter sides together, and so we're going to check this. Is 5 squared plus 6 squared equal, that's a question mark, we don't know, to 8 squared? Well, 5 squared we know is 25, 6 squared is 36, 25 plus 36, if we were adding those together, gives us 61, and that is not equal to 64. So since 61 does not equal 64, this triangle right here with the measurements that they're giving us is not a right triangle. It might look like it from the picture, but because of the sides, the converse says the sides, that this is not going to make a right triangle because our converse does not work. Now, tomorrow in class, we're also going to talk about when you have Pythagorean triples. We'll talk about those a little more in class tomorrow, but right now, we want to look at some theorems or some examples. So if you turn to the next page in your notes you're going to see these written in, and so let's take a look at them. If you now turn in your notes to the guided practice, what we want to do it is you do your problems as you do the worksheet that you're going to be working on. You always want to start as you start the Pythagorean theorem by writing the actual theorem. A squared plus b squared is always equal to c squared. Remembering c is the longest side. So in this triangle, the longest side is always across from the hypotenuse. This happens to be our c. So if we are going to solve this problem, what we are looking for is write this down as I'm doing it. 2.8 squared plus 4.5 squared has to be equal to c squared. This is where your calculator is going to come. If you've taken out your calculator at this point, you're going to put in 2.8 and square it first. So the first thing we do is we write on our paper 7.84. Plus you're now going to put 4.5 in your calculator and square it. That comes out to equal 20.25. Still is equal to c squared. Remember, we're solving for c. We are now going to add on our calculator 20.25 plus 7.84. That comes out to equal 28.09. That's equal to c squared. Now remember in 9-1 when we solve, to get rid of the square, we're going to take the square root. Now I sometimes like to put the c out in front. So instead of putting it behind, putting c squared in front. When we take the square root of c in 9 of square root of c squared, that's just going to equal c. When we did section 9-1, we said positive and negative square root of 28 But most people don't understand what that number is, so we're going to actually use our calculator and find the square root of 28.09. It comes out to be 5.3. So we would say that C is equal to 5.3, and in this case we have our label of inches. Now some of you might be asking, why not negative? Because we're talking about a distance. So our answer is C equals 5.3 inches. We're going to do number 2 together. And in number 2, we are looking at, again, starting with a squared plus b squared equals c squared. But this time, we'll notice one of our legs is missing. So if we want to write 25 as being our a, we have 25 squared plus b squared is equal to 35 squared. Again, if you need to pause the video to write this down, do so. And put it in your calculator, 25 squared. That comes out to equal 625. Plus b squared equals 35 squared on our calculator, comes out to equal 1,225. We are now going to get b squared by itself. So just like in 9-1 when we solved, we're subtract 625 from both sides. B squared is actually going to be equal to 600. What does b equal? We take the square root of 600, which in this case is going to be approximately equal to 24.494, and in this case we'd say centimeters. Since all of our units here were rounded to the whole number, we would then want to round this answer to keep it precise to be 24, in this case, centimeters. But remember, it's approximately 24, it's not exactly 24. I'm going to let you do example 3 for when I return or in class. And example 4 we're going to do together because this is a little different with this square root. Again, we start the same way. A squared plus b squared equals c squared. I am going to use a squared. Instead of b, I'm going to use 2 as being my b. And this is my side c. So I'm now going to put 2 squared equals, and I have the square root of 13, and I'm squaring it. Now the beautiful thing about squaring a square root is it's just like writing that number. If you put in your calculator the square root of 13 and then you get squared, you should get 13. So we now have a squared plus 2 squared is 4 equals 13. We know how to solve this problem. We're going to subtract 4 from both sides. A squared is going to be equal to 9. A equals the square root of 9, which in this case equals 3. Again, remember, we're not going to have positive and negative 3. We're just going to have it left as a positive because we're talking distance. Now, how do you apply the converse? The converse just says that the 2 shortest sides need to be equal to the longest side if it's a right triangle. We think this doesn't look like a right triangle. 12 inches, 13 inches, and 7 inches. It does make a triangle. So when we start off with our a squared plus b squared equals c squared to check our converse, we are going to put down 7 squared plus 12 squared, and the question is, does it equal 13 squared? So on your calculator, what you want to do, 7 squared, hopefully this is one you know, 49, 12 squared, 144, equals 13 squared, again, one of your perfect squares you should know, which is 169. 49 plus 144 gives us 193, and that is not equal to 169. So we would say this is not a right triangle. I want you to use the same thing as we are looking at example 6, 7, and 8. Is it a right triangle? We're going to do 6 together, again, and you will do the last 2. So it's a squared plus b squared equaling c squared. As we do that, we're looking at is 4 squared plus the next shortest side is 5 squared equaling 7 squared. Is 16 plus 25, which when we add those together gives us 41, is not equal to 7 squared, which is 49. So what is our answer? Not a right triangle. Please make sure you do the last 2, and then we will be working on our worksheet. Hopefully it went well.